Okay, so we are going to start off by reviewing exponents and the rules for exponents, just because it's probably been a little while since we fully reviewed these rules. So first, negative exponents, if we're looking at this first little diagram here. So remember, a negative exponent just literally tells us that it's kind of in the wrong place. So if I have a to the negative n, so a negative exponent, then I just place this on the bottom, and I move it to the bottom of the denominator, and then I put a 1 on top. If there's nothing underneath, then there's just going to be a 1 on top. If there is something underneath, then they are going to interact with each other. They may multiply, or there may very well be another thing left on the numerator. It just kind of depends on what you're left with there. But you take the base with the negative exponent and you move it to the bottom, the denominator. If it is in the denominator, then you simply move it up to the top. And since there's just a 1 there on the top, it's just going to be that base with a positive exponent. So it's literally just an indicator that it's in the wrong place. You can also think of it as an indicator of large or small numbers. So if you have a to a negative exponent, like a base to a negative exponent, then it's going to be a small number. It's a number less than 1, basically. So it's a decimal. But if you have a positive exponent, then that's going to be a larger number. Now, again, it doesn't necessarily have to be very large or very small, but that's kind of the basic idea there. And then we could also simplify an expression when we rewrite it with powers of powers, parentheses, or negative exponents. Each base appears only once and all fractions are in simplest form. The following properties are useful when simplifying expressions. So, you know what all that means. We have product of powers. That means that I'm multiplying two powers with the same base. So you see how it's a to the m times a to the n. So they both have a, they both have the same base. So I can take those two exponents and just add them together. So that's product of powers. Product means I'm multiplying. Powers means I have exponents. So I'm multiplying two terms with exponents. Quotient of powers, same idea. It has to have the same bases. And then instead of adding, I'm going to subtract. So just keep in mind, if you're multiplying, multiplication makes things bigger, it's going to increase. So you add. Multiplication, addition go together. Division and subtraction go together because they both decrease. Properties of powers, so this just kind of summarizes a few more powers or properties that we can look at. So this is called a power of a power. So this one, when you see a power raised to another power, instead of adding those, you actually multiply them. With this one, this is it has more than one piece there, and you have to raise every single part of the monomial to that power. So it's kind of like you're distributing that. Same thing with a fraction. If it's raised to a power, you have to distribute it to both the numerator and the denominator. And if it's a negative exponent on a fraction, you're going to flip that fraction over and then apply the exponent. Same idea there. As the negative exponents up here, this is just on a fraction base. Okay, so let's go ahead and practice that. So down here, we're going to group similar factors and then use the properties of exponents to simplify. So I have coefficients, 3, 3, and 3. Oh, it would help if I actually clicked the button here so that you can see that a little bigger. That would have been nice if I clicked on it. I didn't realize I never clicked start on the presentation there. So we have 3, 3, and 3. So I grabbed the coefficients, so you can see those in red. Then I have w squared and w to the 7th. And then I have x and x to the 9th. So I grouped them just so that they're kind of easy to combine. So 3 times 3 times 3, we're actually going to do that. So we get 27. And then because this is a product of powers, meaning I have a w squared times w to the 7th, I'm going to combine it. So it's one base, and the exponents are going to be added together. Same thing with the x's. So x times x to the 9th. This is x to the first power, by the way. There's a 1 here. If you don't see a 1, or you don't see a number for an exponent, the exponent is 1. So now I'm just going to do the simple addition here. I get 27, w to the 9th power, x to the 10th power. All right, so let's take a look at this fraction. So we can flip it over, or we can do the same idea where we can apply that -3 exponent to every piece. You can also flip it over and turn that into a +3. That's perfectly fine as well. I figured because there was already negatives here, I was going to end up having to move things at the end anyway, so I went ahead and did distribution. So 3 to the -3rd. And with this one, I'm applying the 3, and I separated out the -1. So I'm thinking of as -3 times 1. And I did 3 to the 3rd power. That's 27. That's 3 times 3 times 3. And I left the -1 there, so I'll deal with that in a moment. And then we have x, and it's 9 times -3, so that's -27 over -15 times -3. That is +15. That actually means it's in the right place. This -27 is in the wrong place. I need to move this down. So we actually want to move down. There's 27 and 15, so it's -27 minus 15, and you get 42. Because you combine them, it would be a -42, which means that it does in fact need to be on the bottom or in the denominator. And then to make this a positive coefficient, or not coefficient, exponent, I moved the 27 down to the denominator as well. So now it's 27 with an exponent of 1 that we don't need to write there because it's in the correct place. And since everything was moved from the top down to the bottom, we have a 1 in the numerator. It's never just going to be blank. There's going to be a 1 there if everything gets moved. All right, so let's go ahead and try this one. So we have x to the 4th, y to the 7th, divided by x times y to the 6th. So now if I kind of regroup them, remember division means that I'm going to subtract the exponents. So I have 4 minus 1 and 7 minus 6. So I end up with x to the 3rd and just y. So there are no negatives. I don't have to fix anything. That is the answer. I am all done with that one. So that was reviewing the properties of exponents. I hope that helped, and I will see you on the next video.